All right, so today we're going to talk about section 8.1, which is over polar coordinates. So first, let's talk about what they are. So we obviously know how you plot an XY value on a rectangular coordinate system. But now that you guys have learned trig, you know if we took the unit circle, for example, and put it on that XY coordinate plane, we could talk about a point in a different way. So the way we can talk about it is in terms of the angle that creates that ray to get to that point, and that ray we call r, which for the radius, okay? So another way that we can write this, instead of just doing the x, y's, we can express it in what's called polar coordinates. So polar coordinates, they look scary, but they're really not. It's everything we've been doing. So it's r, so the radius length, and then the angle that creates that ray to get up to that point from the x-axis. So it's always from the positive x-axis, just like we learned from a unit circle. So you can kind of see this here in that image. Okay, so let's actually look at an example of this. So if I were looking at this coordinate pair, square root of 3, 1. So my x value is the square root of 3, my y value is 1. So note that the square root of 3 is about 1.73. And also note that we're in the first quadrant. Okay, so now, if we were to do this, if we think about it as a point on a circle, so kind of like imagine that circle there, with the origin being the center of it. So from the origin to that point is going to be the radius of the circle, which we'll call r. And then the angle that's formed from the positive x-axis to that ray is called theta. So we can use our understanding of right triangles to determine the exact value of these two angles. All right, so let's think about what we know. We know this length here is going to be the length of the x value, and that x value was the square root of 3. This length here is the vertical distance, which is the y value, which was 1. So now I'm looking at a right triangle where I've got theta here, r here, 1, and square root of 3. So now it's just using the stuff that we've already learned. So we know that x squared plus y squared equals r squared. So the square root of 3 squared plus 1 squared, oops, not plus, this should be equals r squared. So 3 plus 1 equals r squared, 4 equals r squared, r equals 2. And now we can use that same kind of idea with finding the angle. So remember, using right triangle trig, we know SOHCAHTOA. So looking at this triangle, and if this is our theta, there's our opposite side and our adjacent side. So we're going to be using tangent. So the tangent of theta equals 1 over the square root of 3. Take our tan inverse. Now here's the trick, is you've got to remember what quadrant you're in, because remember the inverse functions are only going to give you for tangent here or here. But luckily this is going to be in the first quadrant, so I'm good to go. So inverse tan of 1 over root 3, and we end up getting that theta is pi over 6. So if we were to write this as a polar coordinate, it would be in terms of r theta. So we would take this point, and if I wrote this in terms of r theta, the radius is 2, the angle is pi over 6. So there's going from rectangular to polar coordinate. So therefore the rectangular point, as we just said, was square root of 3, 1, and then that polar coordinate is 2 pi over 6. And because these points over are equivalent, they should be in the same location whether we plot it on a rectangular system or a polar coordinate system. So for example, if we had to plot these 2 points, I've got like a polar system on top of a xy value or xy coordinate plane. So again, the square root of 3, 1 is going to be a little more than 2 for the x value, and then up 1, so we're going to be right here. And then if we're talking about, so there's the xy value, and then if we're drawing this as a polar coordinate, so radius is 2, so there's 1 unit to that circle, 2 units to that circle, so there's a radius of 2, and then in the angle that's formed with that looks to be about pi over 6. So a polar coordinate system is represented as a series of concentric circles rotating or radiating out of the pole or the origin of the coordinate plane. It's scaled on the unit circle with the positive x-axis called the polar x-axis. So again, if this is our unit circle, that would be 1 unit for the radius, and then there's 2 units when you get to that second circle. So it's kind of how far out to go. Okay, so if we were plotting points using coordinate systems, the first thing that we're going to do is we're going to first draw 360 degrees. So if we had that, so this is your radius, this is your theta. So the first thing that we want to do is first draw an angle of 60 degrees. So an angle of 60 degrees is going to take us to about right here. Now, what you're going to want to do to deal with this radius is you need to draw a real number line. Remember real number lines when you were learning basic math are just like this, where you've got the 0, 1, 2, -1, -2. So we're going to draw a real number line on here. 0 is right here at the origin, so if my radius is +3, I'm going in the positive direction 3 units. So that would put this point right here. Now, angles can be measured in both degrees or in terms of radians. In addition, the value of r can be positive or negative. So if the value of r is negative, this is what ends up happening. Same thing, so you first draw, like if we had the point -3 60 degrees. First thing you're going to do is you're going to draw the -60 or the 60 degree angle. Then, again, extend that number line out. So there's your 60 degrees. But now instead of going in the positive direction on the real number line, we're going to go in the negative. So this would be like -1, -2, -3. So that's going to put this point right here. In other words, another way to kind of look at it is it reflects it 180 degrees or pi. So for example, if we needed to plot the point for 2 pi over 3, let's do that really fast. All right, so the first thing we do is do this angle. So the angle is 2 pi over 3. 2 pi over 3 is going to end up taking me over here. Okay, so there's 2 pi over 3 right here. And then what we need to do is we need to plot that, so we need a radius of 4. So if this was my real number line, again, here's the positive, this would be the negative direction, so it'd be 1, 2, 3, 4. So right there would be where our point would be. What's kind of cool is you guys learned in the unit circle that you could go around multiple times to get to the same value. So you can find various coordinate points for polars by using this formula. So I don't know why this line got so messed up, but it's r is the x value. I'm going to write it on here so it's not this weird extra line. So r and then theta plus 2 pi k, because we know that this angle here can be, if I went around the unit circle 1 full time, so 2 pi units, would land me still at that same exact value. Or again, if we did the negative r, it would be reflecting it over the 180 degrees, so pi. So add pi to that. So that's how you can find all the different iterations of writing the same point.